Hello, I'm David Brown at Berkeley Nucleonics, and this video series is going to walk you through all the features and functionalities of SpectraCore, our newly released software tool that matches up with the beautiful new RTSAs, the ICX400. Each feature will be defined in a small video so you can bounce around to just the features you need. Please reach out to us so we can answer any questions you have and get your hands on one of the new 40 gigahertz real-time spectrum analyzers on Berkeley Nucleonics. Today we're measuring displayed average noise level, or DANL, across different frequency bands and reference levels in SpectraCore. Our F-link noise and gain both affect DANL differently depending on the band, so you'll want to set your target band and reference level to match what you're actually testing. In this example, we're measuring DANL from 1 gigahertz to 2 gigahertz at a reference level of negative 20 decibel milliwatts. Open SpectraCore set start frequency to 1 gigahertz, stop frequency to 2 gigahertz, and reference level to negative 20 decibel milliwatts. Set video bandwidth to 1 kilohertz that smooths out the noise trace and improves measurement accuracy. Set spurious rejection to bypass, window type to flat top, and the trace detector to RMS. Double click the spectrum graph to activate a marker, and then in the marker submenu of the chart settings area, turn on noise density and read the normalized power density. That's your DANL value, measured as average power at a resolution bandwidth of 1 hertz. Because it's normalized that way, DANL stays the same no matter what resolution bandwidth you're actually using. Thanks for watching. Let's move on to the next software tool in SpectraCore to get you most out of your ICX Fieldhawk, the 40 gigahertz spectrum analyzer.